Hello dear students, all of you welcome to Vidyan classes. Today we will discuss some important problems on determinant. Question number 1. If ABC are all real, then show that the minimum value of the determinant is 1. Let del be the given determinant. So del is equal to ABC divided by ABC into determinant having elements a square plus 1 AB AC AB B square plus 1 BC AC BC C square plus 1. ABC by ABC cancels, del is the given determinant. Which is same as ABC into multiplying 1 by A in row 1, 1 by B in row 2 and 1 by C in row 3. It gives A plus 1 by B C. Multiplying 1 by B in row 2, A B plus 1 by B and C. Multiplying 1 by C in row 3, it gives A B C plus 1 by C. Applying row 1 is replaced by 1 by A row 1. Row 2 replaced by 1 by B row 2. Row 3 is replaced by 1 by C row 3. Clear? Which is same as ABC into determinant having elements A square plus 1 divided by A B C A B square plus 1 divided by B and C A B C square plus 1 divided by C, which is same as A square plus 1 A square B square plus 1 and B square C square plus 1. Applying column 1 is multiplied by A C1. Column 2 is multiplied by B. Column 3 is multiplied with C. ABC are the real numbers. Whenever a scalar is multiplied with a determinant, then it will be multiplied in any one of the rows or columns. A is multiplied along column 1, B is multiplied along column 2, C is multiplied along column 3. Applying column 1 is replaced by column 1 plus column 2 plus column 3. The given determinant del is equal to 1 plus a square plus b square plus c square. 1 plus a square plus b square plus c square. 1 plus a square plus b square plus c square. b square plus 1 b square c square c square c square plus 1. Column 1 is replaced by column 1 plus column 2 plus column 3, which is same as 1 plus a square plus b square plus c square. Taking 1 plus a square plus b square plus c square as common from column 1, it gives 1, 1 and 1. b square plus 1 b square. c square c square plus 1. Taking 1 plus a square plus b square plus c square as common from column 1. Applying row 1 is replaced by row 1 minus row 2, and row 2 is replaced by row 2 minus row 3. Row 1 is replaced by row 1 minus row 2, row 2 is replaced by row 2 minus row 3. The given determinant del will be 1 plus a square plus b square plus c square. It gives 0, 0, 1. b square minus b square plus 1, that is minus 1. b square plus 1 minus b square, that is equal to 1. 0, c square minus c square plus 1, that is minus 1. c square plus 1. Clear? Which is same as 1 plus a square plus b square plus c square. Expanding along column 1. Expanding along column 1 into 1, 1 minus 1 into minus 1, 1 minus 0. Expanding along column 1, which is equal to 1 plus a square plus b square plus c square. The given determinant del is equal to this. Implies as del is equal to 1 plus a square plus b square plus c square. For all ABC belongs to R. R means set of real numbers. A square plus b square plus c square greater than or equal to 0. For any real number, a square plus b square plus c square greater than or equal to 0. If ABC all are 0, then a square plus b square plus c square equal to 0. Otherwise, it is greater than 0. Which implies as 1 plus a square plus b square plus c square greater than equal to 0 plus 1, that is equal to 1. Which implies as del greater than equal to 1. Therefore, the minimum value of del is 1. Clear? So that the minimum value of the given determinant is 1. The given determinant is taken as del. Del is greater than or equal to 1. Therefore, the minimum value of del is 1. Hence proved. Hence proved. Clear? Okay, write down. Question number 2. So that for each real value of lambda, the system of equations lambda plus 3 into x plus lambda y is equal to 0 and x plus 2 lambda plus 5 into y equal to 0 has a unique solution. So that for each real value of lambda, the system of equations has a unique solution. The system of equations has unique solution if del not equal to 0. The system of equations has unique solution if del not equal to 0, where del is the determinant of coefficients of x and y, where del is the determinant having elements lambda plus 3, lambda 1, 2 lambda plus 5. Clear? Okay. To show lambda not equal to 0, since the system of equation has unique solution, for unique solution del not equal to 0. To show del not equal to 0 for all lambda belongs to set of real numbers. We have to prove lambda not equal to 0 for all lambda belongs to R. Now lambda is equal, del is equal to, del is the determinant, this into this, that is 2 lambda square plus 5 lambda plus 6 lambda plus 15 minus lambda, which is the same as 2 lambda square plus 10 lambda plus 15, which is same as 2 into lambda square 5 lambda plus 15 by 2. 2 into lambda square plus 10 lambda plus 15. We have to show del not equal to 0. 2 into lambda square plus 2 lambda into 5 by 2. 2 cancel, that is 5 lambda plus 5 by 2 whole square plus 15 by 2 minus 25 by 4. 5 by 2 whole square, that is 25 by 4. 25 by 4 minus 25 by 4 cancelled. It is same as lambda square plus 5 lambda plus 15 by 2. This and this are cancelled. This value is 2 into lambda plus 5 by 2 whole square. This value is lambda plus 5 by 2 whole square. This value plus 30 minus 25, that is 5 by 4, which is same as 2 into lambda plus 5 by 2 whole square plus 5 by 2. Implies as del is equal to 2 into lambda plus 5 by 2 whole square plus 5 by 2. 5 by 2. 2 into 5 by 4 is equal to 5 by 2. Greater than or equal to 5 by 2. For all lambda belongs to set of real numbers. Lambda is equal to minus 5 by 2. The value is 5 by 2. Otherwise, it is greater than 5 by 2. For lambda is equal to minus 5 by 2, this term is 0. The value is 5 by 2. Otherwise, the result is always greater than 5 by 2. Implies as del greater than equal to 5 by 2 for all lambda belongs to set of real numbers. Therefore, del not equal to 0. For all lambda belongs to set of real numbers. To show del not equal to 0 for all lambda belongs to R. Hence the statement is proved. To show del not equal to 0 for all lambda belongs to R. Here del not equal to 0 for all lambda belongs to R. Clear? Most important question. Council question 2014. Clear? Okay. Next, find the value of the determinant without expanding. Let del be the determinant having elements 17, 18, 97, 19, 60, 99, 18, 59, 98. Applying row 1 replaced by row 1 minus row 2 and row 2 replaced by row 2 minus row 3. Del is equal to minus 2, 18 minus 16 minus 42 minus 2, 97 minus 99, 19 minus 18, 1, it is also 1 and it is 1, 18, 59, 98. Here row 1 is replaced by row 1 minus row 2, row 2 is replaced by row 2 minus row 3. Apply row 1 replaced by row 1 plus 2 times of row 2 implies del is equal to minus 2 plus 2 that is 0, minus 42 plus 2 that is minus 40, minus 2 plus 2 that is 0, 1, 1, 1, 18, 59, 98. Row 1 contains maximum zeros. Expanding along row 1. Expanding along row 1. Del is equal to minus of the sign of minus 40 is negative, minus 40 into deleting this row and this column 1 into 98 minus 1 into 18 which is equal to 40 into 80 which is equal to 3200. Therefore, del is equal to 3200. The value of del is 3200. Clear? Question number 4. Prove that value of the determinant is equal to 2 into a plus b into b plus c into c plus a. Proof. Let del be the determinant having elements a plus b plus c minus c minus b minus c a plus b plus c minus a minus b minus a plus b plus c. Applying column 1 replaced by column 1 plus column 2. Column 2 replaced by column 2 plus column 3. Implies this del is equal to a plus b minus of a plus b. C2 is replaced by C2 plus C3 minus of b plus c. b plus c and b plus c. Minus b minus a plus b plus c. To be same as taking a plus b from column 1 and b plus c from column 2. A plus b into b plus c into determinant having elements 1, 1, minus 1. Minus 1, 1, 1. Minus b minus a plus b plus c. Which is same as a plus b into b plus c applying C1 is replaced by C1 plus C2. A plus b into b plus c into determinant having elements 0, 2, 0. Minus 1, 1, 1. Minus b minus a plus b plus c. Column 1 contains 2 zeros. Expanding along column 1, which is same as a plus b, b plus c into the sign of 2 is negative, minus 2 into deleting second row and first column, it gives minus of minus a minus b minus c plus a. Sorry, it is The sign of 2 is negative. Deleting the second row and the first column. Minus of A, minus of B, minus of C, plus B. B cancel, which is equal to 2 times of A plus B, B plus C into A plus C. This into this, minus A minus B minus C. This into this, minus B. Therefore, del is equal to 2 times of A plus B, B plus C, C plus A. Hence proved. Clear? Council question 2008 instant exam. Clear? Okay. Next question number 5. Solve the determinant. Using the diagonal property or expanding along row 1. Expanding along row 1 implies x minus a into this x minus b into x minus c minus 0 is equal to 0, which implies x minus a into x minus b into x minus c is equal to 0. Implies x is equal to a or b x minus a is equal to 0 or x minus b is equal to 0 or x minus c is equal to 0. Implies x is equal to a or x is equal to b or x is equal to c. The value of x is a or b or c. Clear? One more question, council question 2006. Note down. Question number 6. The system of equations has infinitely many solutions. Then find the values of lambda. Lambda x plus 3y is equal to 0. X plus lambda minus 2 into y is equal to 0 are the given system of equations. The system of equations has infinitely many solutions if del is equal to 0, del 1 is equal to 0 and del 2 is equal to 0. The system equations has infinitely many solutions if these conditions are satisfied. Clearly, del 1 is equal to 0 and del 2 is equal to 0 as del d1 is equal to 0, it is d1 and it is d2 is equal to d2. Now, del is equal to 0 implies this. Del means coefficients of x and y. Coefficients of x and y. It gives lambda 3, 1, lambda minus 2 is equal to 0. Del means coefficients of x and y. Determinant of coefficients of x and y. It is a del, which implies is lambda square minus 2 lambda minus 3 is equal to 0. Which implies is lambda square minus 3 lambda plus lambda minus 3 is equal to 0. Which implies is lambda into lambda minus 3 plus 1 lambda minus 3 is equal to 0. Lambda plus 1 into lambda minus 3 is equal to 0. That implies lambda plus 1 is equal to 0 or lambda minus 3 is equal to 0. That implies lambda is equal to minus 1 or lambda is equal to 3. Therefore, lambda is equal to minus 1 or 3. Clear? The system equations has infinitely many solutions, implies del is equal to 0, del 1 equal to 0 and del 2 is equal to 0. Del 1 and del 2 both are 0 as d1 is 0 and d2 is 0. Now del is equal to 0. Del means determinant having the elements, that means coefficients of x and y. Determinant having elements as the coefficients of x and y. On solving, it gives lambda is equal to minus 1 or 3. Next, without expanding, find the value of the following determinant. Let del be the given determinant having elements 3, 6, 9, minus 2, 4, minus 6, 8, 16, 24. Which is a match. Taking 3 from row 1 and taking 8 from row 3. Taking 3 from row 1 and taking 8 from row 3 as a common, it gives 1, 2, 3. Minus 2, 4, minus 6. 1, 2, 3. Which is equal to 24 into 0. Since row 1 is equal to row 3. The value of the determinant is 0 if any two rows or any two columns are identical. That means same. Here row 1 is equal to row 3. So del is equal to 0. Implies this del is equal to 0. The value of the determinant is 0. It is the answer. Clear? Okay. Write down. Question number 8. So that value of the determinant is equal to a minus b into b minus c into a minus c into abc minus sq. Let del be the given determinant. AQ minus SQ, BQ minus SQ, CQ minus SQ. A square, B square, C square. ABC. Let del be the given determinant. Using the sum property, del can be written as AQ, BQ, CQ, A square, B square, C square, ABC plus minus SQ minus SQ minus SQ, A square, B square, C square. The first column is the sum of two elements, the second column contains single elements, the third column contains single elements. So the number of determinants as a sum is equal to 2 into 1 into 1, that is equal to 2. The number of determinants is the sum of two determinants using sum property, which is same as AQ, BQ, CQ, A square, B square, C square, ABC minus SQ 1, 1, 1. A square, B square, C square, ABC. Clear? Okay. ABC into 1 A square A 1 B square B 1 C square C 1. Taking A as common from row 1, taking B as common from row 2 and C as common from row 3. So this determinant can be written as ABC into determinant having elements A square A 1, B square B 1, C square C 1 minus SQ A square B square C square 1, 1, 1 ABC. Row 1 and row 2 are interchanged. C1 is replaced by C2, C2 is replaced by C1. If two adjacent rows or columns are interchanged, then the sign of the determinant changes. So it will be plus. Column 1 and column 2 are interchanged. So the sign changes. which is same as ABC A square B square C square. ABC 1 1 1. Interchanging column 2 and column 3. Interchanging column 2 and column 3. The sign changes, it will be minus SQ into A square B square C square. ABC 1 1 1. Column 2 and column 3 are interchanged, so the sign changes. Taking the determinant as common, taking the determinant as common, it gives ABC minus SQ into determinant having element A square B square C square ABC 1 1 1. Clear? Applying row 1 is replaced by row 1 minus row 2, and row 2 is replaced by row 2 minus row 3. Which is same as ABC minus SQ into determinant having elements A square minus B square, B square minus C square and C square, A minus B, B minus C and C. It is 0 0 1. Clear? Okay. Taking A minus B as a common from row 1 and B minus C as a common from row 2, it gives ABC minus SQ into A minus B, B minus C into determinant A plus B 1 0. B plus C 1 0. C square C 1. Clear? Taking A minus B from row 1 and B minus C from row 2, which is same as ABC into SQ A minus B, B minus C. Column 3 contains 2 zeros. So expanding along C3, column 3, it gives expanding along column 3. The sign of 1 is positive, 1 A plus B minus B plus C, that is minus B minus C. B cancel, it gives ABC minus SQ a minus b, b minus c into a minus c. Clear? Therefore, del is equal to, del is the given determinant, is equal to ABC minus SQ, A minus B, B minus C into A minus C. Proved. So the given statement is proved. Clear? Okay. Next, question number 9. Question number 9. Solve the equation of a determinant. Solve the equation of a determinant. Given determinant having elements 15 minus 2x, 11 minus 3x, 7 minus x, 11, 10, 17, 16, 14, 13 is equal to 0. Applying C2 is replaced by C2 minus C3. The equation of a determinant will be determinant having elements 15 minus 2x, 11 minus 3x, 7 minus x, 11 minus 10 that is equal to 1, 17 minus 16 1, 14 minus 13 1, 10, 16, 13 is equal to 0. Clear? Okay. Applying row 1 is replaced by row 1 minus row 2 and row 2 is replaced by row 2 minus row 3. It implies determinant having element 15 minus 11 that is equal to 4 plus x. 1 minus 1 that is 0, 11, 10 minus 16 minus 6. 11 minus 3x minus 7 minus of 7 minus x that is 4 minus 2x. 1 minus 1 0 and it is 3. 7 minus x 1 13 is equal to 0. Here column 2 contains maximum zeros. So expanding along column 2, expanding along column 2, it gives 0, minus 0, minus 0, 0, 1, minus 1. Minus 1 into the sign of 1 is negative, its value is 0, its value is 0, negative of 1. Deleting the third row and the second column, it gives 3 into 4 that is 12 plus 3x, minus of 24, minus plus 24, minus 12. 24 minus 12x is equal to 0. which is same as 36 minus 9x is equal to 0. Nine x is equal to 36, x is equal to 4. Therefore, x is equal to 4. This is the solution. The solution of the equation of a determinant, x equal to 4. Are you clear? Okay. Write down. Question number 10. If capital Fx is the determinant of order 2, then its derivative is the sum of two determinants each having order 2. Prove given capital Fx is equal to determinant having elements f1x, f2x, g1x, g2x is the given determinant, which implies expanding this determinant fx is equal to f1x g2x minus f2x into g1x. Differentiating both sides with respect to x. Differentiating both the sides with respect to x implies f dash x is equal to, it is the form of u into v. That means first derivative second plus second derivative of first. f1 dash x into g2x plus f1x g2 dash x, dash means derivative, minus f2 dash x into g1x minus f2 x into g1 dash x. Second derivative first plus first derivative second. We have to prove this result. F dash x is equal to determinant having elements f1 dash x g1 dash x f2 x g2 x plus determinant having elements f1 x g1 x f2 dash x g2 dash x. We have to prove the derivative of fx, capital Fx, which represent determinant having elements, derivative of first column. It is the first column. Derivative this and the derivative this, plus derivative of second column f2 dash x g2 dash x. We have to prove f dash x is equal to this. This can be by the rearrangement. It represent f1 dash x g2 x by the rearrangement minus f2 x g1 dash x. By the rearrangement, we have f1 dash x into g2x minus f2x g1 dash x. That means it is the first term, it is the second term, plus f1x g2 dash x, f1x g2 dash x minus f2 dash x into g1 x. f1x g2 dash x, this, and f2 dash x g1 dash x, g1x, this minus this plus this minus this, but this is same as this and this is same as this. So f dash x, expanding this determinant, it gives this result, and expanding this determinant, it gives this result. So f dash x is equal to this. Clear? Clear? Okay. For example, let capital F is the determinant having elements 1, x, s square and sin x. Implies f dash x derivative of fx means derivative of first column. It gives derivative of first column. Derivative of 1 is 0, derivative of s square is equal to 2x, and the second column remains silent. Clear? Derivative of x means derivative of the elements of a first column and the second column remains silent, plus the first column remains silent, 1 s square. Derivative of the elements of a second column. Derivative of x with respect to x is 1, and derivative of sin x with respect to x is equal to cos x. It is the derivative of fx for order 2. Similarly, for order 3, it is order 2. For order 3, let capital Fx is the determinant having elements f1x, f2x, f3x, g1x, g2x, g3x, h1x, h2x and h3x. It is a determinant of order 3. Similarly, derivative of capital Fx is equal to f1x, f2x, f3x, g1x, G2x, G3x, H1x, H2x, H3x plus F1x, F2x, F3x, G1x, G2x, G3x, H1x, H2x, H3x plus determinant having elements F1x, F2x, F3x, G1x, G2x, G3x, H1x, H3, H2x and H3x. Differentiating capital Fx with respect to x, it gives, for order 2 we have derivative of the elements of first column. So derivative of the elements of first column f1 dash x, g1 dash x, h1 dash x, derivative of the first column. Derivative of the second column f2 dash x, g2 dash x, h2 dash x. Dash means derivative with respect to x. And the derivative of the elements of a third column f3 dash x, g3 dash x and h3 dash x. Clear? For example, capital Fx is equal to determinant having elements 1, minus 2, 3. X minus s square s cube. 1 e to the x cos x. It is a determinant of order 3. F dash x, derivative of fx with respect to x is equal to derivative of the first column. Derivative 1 is 0. Derivative of x with respect to x is 1. Derivative of 1 is also 0. Column 2 and column 3 remains silent. Minus 2 minus s square e to the power x. 3 s cube cos x plus derivative of the elements of a second column. First column remains silent 1 x 1. Derivative of minus 2 is a constant. Derivative of constant is 0. Minus s square minus 2x. Derivative of e to the x is e to the x. 3 s cube cos x plus first column remains silent 1 x 1. Second column remains silent minus 2 minus s square and e to the x. Derivative of the third column, derivative of the elements of third column, it gives derivative of 3, derivative of constant is 0, derivative of s cube That means derivative of s to the n 3s square. Derivative cos x minus sin x. Capital Fx is the determinant of order 3. Its derivative is the sum of 3 determinants, each having order 3. Here, capital Fx is the determinant of order 2. Its derivative is the sum of the 2 determinants of order 2. Here, capital Fx is the determinant of order 3. Its derivative is the sum of 3 determinants, each having order 3. Derivative of a function means first derivative first column, derivative of second column, derivative of third column. Clear? Okay. Note down.